All right, so welcome back. In previous video, we talked about the setup for finding volumes using shells. And so once again here, we're looking at a situation where we have a volume. This time, we were revolving about the y-axis. So we're looking here at x minus x squared. The area between that and y equals 0. So in other words, this area here, we're going to take this region and we're going to revolve it about the y-axis. So first of all, think about the kind of shape you get. This is going to be a parabola shaped donut that's kind of flat on the one end, and it actually comes down to a point inside the middle of the donut where it actually has like a little cone inside the donut there. So kind of a neat little shape that we end up getting here. But the problem is, if we tried to do this with washers, then we'd have to run perpendicular to the y-axis, and we would actually be looking at the difference between one wing of this parabola and the other wing. That would mean we'd have to solve the equation. It would actually involve the quadratic formula. It would be a little messy. Okay, a little messy doing that. So instead, we're going to use shells. So we run parallel to the axis. That's the difference between shells and washers. The shells run parallel. And again, we're looking then at the height of that piece, which is our function y equals x minus x squared. Okay? And then we use our shell formula. Right? Because again, if we tried to do the volume with the disc or washers, then we would be doing horizontal perpendicular to the axis. Right? And that would require me to do the difference between this part of the parabola and this part, which can be done, but it's pretty rough. It's pretty rough. So instead, we're going to use shells. And again, the formula for shells, as we talked about previously, is the integral of cross your range of 2 pi x times f of x, where again f of x is going to be the height of that cylindrical shell. The height of that cylindrical shell. Okay. So let's go ahead and do that. So here we see this is going to go along the x-axis. First of all, between 0 and 1. So we're integrating with respect to x, but we are revolving about y because we're using shells. So volume be the integral from 0 to 1 of 2 pi x times f of x, x minus x squared, dx. All right, and then we just start to work out our integral. And after this point, it's pretty straightforward. So we bring 2 pi out, integral of x squared minus x cubed, dx. 2 pi outside, and we do our integral. So 1/3 x cubed minus 1/4 x to the 4th. And we're evaluating between 0 and 1. It looks like I lost my limits here, so let me roll them back on here. 0 to 1. Right. And then we just compute that. It's just going to be basically 1/3 minus 1/4, which will actually be 1/12, times 2 pi, will be pi over 6. Okay, so kind of straightforward. There. Again, using shells. And again, the reason we're using shells is because, once again, it's difficult. It's more difficult. It's not impossible, but it's more difficult to try and do it using washers. That's why we have the two methods, because there's Usually if one way is hard, the other way might be easier. And that's what we're encountering in this first example.